Hello, this is Mrs. James. This is our end of course review sessions, our last minute topics. This is Waves Part 1. If you did not see the nuclear chemistry topics, there are 3 of them. They are 10 minutes, 10 minutes, and 4 minutes long, and you can watch those yourself on YouTube. Alright, so supposedly you learned about waves in middle school, and this is what you learned in middle school. You learned about waves transmitting energy between objects. You learned how to describe them by their speed, their wavelength, their frequency, their amplitude, and those relationships. And you learned how to apply those to earth science. Now, I know in reality that perhaps you didn't get this, so let's do a little tiny review of those topics before we move on. Alright, let's summarize. 2 basic types of waves, transverse and longitudinal. And here's a little sketch of them, which you might be able to copy there into your own notes. The hand is not important. Remember, I'm showing a slinky here, but this doesn't mean that all waves travel through slinkies. Alright, this is just a slinky to give us an example. A transverse wave goes like this. The slinky goes back and forth, and the energy travels this way. That's the way the energy goes. So let's put a little arrow there. This is the direction that the energy travels. Now, the word trans means across. So the motion of the slinky is across the motion that the energy goes, and that's why it's called transverse. Now, there's a second type of wave called a longitudinal, and if you take a little slinky and if you send a pulse through it, the pulse will travel. So here's a place where the pulse is, here, and here, and here. And here's a space where the slinky gets stretched a little farther apart than usual. The places where it's pushed together is called a compression, and the places where it is expanded is called an expansion or a rarefaction. And again, the energy is traveling this way, but this time the motion of the slinky is along the flow of energy, so it's called a longitudinal wave. Alright, so our 2 basic kinds of waves, they don't have to go through slinkies. They can go through water, they can go through air, they can go through a string, and some of them can go through a vacuum of space, and specifically a transverse wave. Now there's another word here for you to see that we'll discuss more later. It's called wavelength. From one point on a wave to the identical point of that wave later on is called one wavelength. So we can look at the wavelength of a transverse wave, or we can look at the wavelength from one compression to another of a longitudinal wave. These are important words for you. You should learn them. Alright, now let's talk about a word called medium. Medium is just a fancy word, a way of saying matter. Air is a medium, water is a medium, string is a medium, slinky is a medium. Transverse waves do not require a medium, but longitudinal waves do. So if there's no medium, no matter, a longitudinal wave can't travel. Light is a transverse wave. Sound is a longitudinal wave. This makes sense. You can see the sun, but you can't hear it. Alright, you can see it because light is transverse. It doesn't need a medium, so it can go through space. Sound is longitudinal. It does need a medium. There's no matter in space, so the sound of the sun, that roaring sound that it should make since it's engulfed in those flames that you see, you can't, and that's because it's longitudinal. Alright, let's talk about 2 important terms, wavelength and frequency. We have 2 waves here for comparison. We have a wavelength marked for both of them. We would say that this wave up here has a shorter wavelength, this one has a longer wavelength. A second important word is the word frequency. This has to do with how frequently a wave would move past an object, how frequent the objects are, and it's measured in cycles per second, and a cycle per second is called a hertz. Now this one has a shorter wavelength, but it's more frequent. So it has a low wavelength and a high frequency. This one has a longer wavelength, but it's going to be less frequent. So we would say it has a higher wavelength and a lower frequency. Whenever you talk about wavelength, you're automatically talking about frequency too. Now, when waves happen near us, we can interpret some of those waves. We can interpret light waves. We can interpret sound waves. When light waves have different frequencies and wavelengths, our eyes see those as different colors. When sound waves have different frequencies and wavelengths, our ears interpret those as different pitches. So this, if this was a light wave, it would be a different color than this one would be. A red wave would have a longer wavelength than, say, a violet wave. A longer wavelength sound has a lower pitch, like lower on the scale, and a smaller wavelength, higher frequency pitch, a sound wave, has a higher pitch. It's higher on the scale. Okay? Now, some of you are saying, but wait a second, that's a transverse wave and sound is a longitudinal wave. You're right, it is. Let's go back and look at this picture. It's really hard to keep drawing these waves right here. Look how easy it is to draw a transverse wave. All I have to do is draw a little swoop like this, but it's harder to draw those compressions and rarefactions of a longitudinal wave, so most people, including the people who write textbooks and who make websites, usually will draw a sound wave like a transverse wave, even though it isn't. So don't let that worry you. Again, the important thing here is that our brain and our eyes and our ears interpret different wavelengths and frequencies as different colors and pitches. Now, the third important vocabulary word is velocity. If you multiply the wavelength times the frequency of a wave, you get its velocity. The velocity of a wave doesn't usually change unless the wave enters a new medium. So if a light goes from, say, air into glass, it will slow down. But otherwise, it will keep going the same speed. So, therefore, whenever the wavelength of an object changes, its frequency automatically will change also, and the other way around. If you need to stop the video for a few minutes, pause it so you can write all this down, then please go ahead and do that. Alright, what happens when a wave hits something? There are three basic things that can happen. First off, the wave might bounce back. When it does that, it's called reflection, and a wave will bounce back at the same angle that it hits. It might do what's called refract. Refraction is when a wave goes through an object, but as it goes through, it slightly changes paths. And I believe that you studied refraction in junior high, and this is why when you look at a straw and a glass of water, the straw appears to be bent or offset, even though it's not. So let's draw a little picture for you here. This is going to represent a glass of water, and this will represent the surface of the water. And if you look at this from the side, you will see your straw would be like this, but then when it leaves the water, the straw appears to be a little bit offset like that. And the thing that causes that is the refraction. When we cover this material in class, we will spend a little bit more time talking about this, but I think most of you have seen this phenomenon happen. Alright, and the third thing that can happen is absorption. You might have the word transmission here in your notes, your printed notes. If you do, please delete it. It should be the word absorption. Sometimes waves get absorbed. When they do, they get turned into heat energy. And normally when people talk about this, they usually talk about it when they're talking about light waves, but it also could happen to sound waves. So three things, and I suggest that you memorize these three things. Sometimes multiple of these happen at the same time. So sometimes a wave is partly reflected and partly absorbed, as an example. Alright, now it gets a little trickier. This is the thing we have to talk about next, is what happens when a wave hits another wave. So we need more time for that, so we will stop this video and we will pick it up in our next edition.